Hello, I hope this helps you with your evaluating the six trig functions when the things are in radian measure. First thing I want to do is show you the unit circle with the special angles all filled in. And I can get you a copy of this as well if you would like. This is 30 degrees. If I want to change 30 degrees to radian measure, so if I want to go from degrees to radians, I multiply by pi over 180. Because pi is halfway around a circle and 2 pi is all the way around when you're using the formula 2 pi r for circumference, and our radius is 1. So 2 times pi times 1 would be 2 pi for all the way around, 1 pi for halfway around. So if you did 30, you would be taking 30 times pi over 180. And that gives you 30 pi over 180, which if you reduce that fraction, you would get pi over 6, or 1/6, so that's where I'm getting pi over 6. You can do all of those all the way around. I will fill them in for you, so you have this. This is pi over 4. This one would be pi over 3. 90 degrees, if that's 1 pi, then this would be half of a pi, which we write as pi over 2. 120 is 2/3 of the way over. Again, if you're like, I don't see that, you can just multiply each degree by that. 135 is 3 pi over 4. 150 is 5 pi over 6. So forth. I'll fill these in. 7 pi over 6. We're down here at 210. The next one is 5 pi over 4. Or 1 1/4 pi. 240 is 4 pi over 3. 270, 3 pi over 2. 1 1/2 pies. 300 would be, oh, excuse me, I have that at the wrong spot. 300 degrees, or 5 pi over 3 radians. 315 degrees is 7 pi over 4 radians. 330, pardon me, that should say 30, is 11 pi over 6 radians. Okay, so I filled in all the degrees around the unit circle, and then I wrote their matching radian measurement. Now, I just want to show you where each of the ones come from that we give you. If this one right here is 30 degrees, and we go straight down to create a right triangle, I think you saw a video on this, the radius of the unit circle is 1. So, let me show you. On the back, I hope you remember these relationships from geometry for a 30, 60, 90 triangle. The hypotenuse in all of our triangles will be 1. So 2 times what number is 1? Well, 2 times a half. So the short leg will always be a half, and the long leg will always be √3 over 2. So then if I go back here, this first yellow line is 30 degrees. So this triangle that we created, the hypotenuse is 1. Over here would be the short leg, which is a half, and the long leg, which is √3 over 2. Making the x, how far you go over, √3 over 2. And the y, how far you go up, 1/2. Now, I'm not sure if you caught this from the information that they gave you on Odysseyware, but the x value is your cosine, and the y value is your sine. Now, what's nice about all the ones I highlighted in yellow is if you make a triangle for each one of these by going straight to the x-axis, 150 is 30 degrees away from 180. So your hypotenuse is 1, your short leg is 1/2, and your long leg is √3 over 2. The only thing different for these that are in yellow is that the x, you're going left, so that would be negative √3 over 2. And going up is positive 1/2. So cosine of 150, or 5 pi over 6, would be negative √3 over 2. The sine, or the y value, would be 1/2. So down here, same thing. You're going left a long leg, so that's negative √3 over 2. And down, anytime you go down, that's negative. And that's your short leg. So all of these have the same X and Y, you just need to be careful on the sign. Like this is a long way over, root 3 over 2, and a little down, which makes that negative. Now, all the ones in purple are 60 degrees from the x-axis. I know this is probably getting a little sloppy here, but if I go straight down to the x-axis, I again have a 30, 60, 90 triangle. Hypotenuse is 1. So my short leg, I go a little bit over, that's 1/2, and a long way up, that's root 3 over 2. So for these, just be careful with your signs. All the ones that end in purple will be 1/2 root 3 over 2. 1/2 root 3 over 2. 1/2 root 3 over 2. Just be careful with your signs. In the second quadrant, your x is negative. In the third quadrant, x and y are negative. In your fourth quadrant, the x is positive, but the y is negative. Now, I hope you saw from the other one that we also have another triangle that's special and from geometry. It is the 45, 45, 90 triangle. I'm hoping these relationships look familiar to you. But I'm telling you that the hypotenuse is 1 because the radius of our circle is 1. So how I got these sides was, if you look, to get the hypotenuse, you multiply by root 2. So if I want to go backwards and just find what the legs would be, I would take the hypotenuse and divide by root 2, which, if I rationalize that, I get root 2 over 2, and that's what I have for both the legs. So for all of our ones that are in the middle, that would be all the pink ones. That's your pi over 4, your 3 pi over 4, your 5 pi over 4, and your 7 pi over 4. All those in the middle have the same x and y, same cosine and sine. Root 2 over 2, root 2 over 2. Root 2 over 2, and root 2 over 2. Root 2 over 2, and root 2 over 2. Just watch your signs. So here they're both positive. In this quadrant, the x is negative. In this quadrant, they're both negative. And in this quadrant, your y is negative. I don't think they ask you any of these, but the ones that are right on the axis, if the radius is 1, then that's just 1 to the right and 0 up and down. This one at 90 is 0 left and right, but 1 up. At 180, it's negative 1 to the left because it's 1 over, and since I went to the left, it's negative. 0 up and down. Down here at 270, or 3 pi over 2, is 0 left and right, negative 1. So if you had pi over 6, which is the same as 30 degrees, 5 pi over 6, which is the same as 150, 7 pi over 6, which is the same as 210, 11 pi over 6, which is the same as 330. The x's are root 3 over 2. The y's are 1/2. Just be careful with your signs depending on the quadrant. So the x value is cosine. The y value is your sine. So think about where it is. Same thing with the pinks. Same thing with the purples. So that hopefully can help you do the cosine and sine ones. Now, let's see what else I want to show you. Just a reminder that these, cosine is x, sine is y, secant is the reciprocal of cosine, cosecant reciprocal of sine, and since sine is your y, you can just flip the y. Tangent is y divided by x, and cotangent would be the reciprocal of that. Let me just give you an example, make sure you'd be okay. So if I asked you to evaluate cosine 7 pi over 6, okay, so I need the x value at 7 pi over 6. So let's look. 7 pi over 6, the x value is negative root 3 over 2. If I wanted the sine value at 7 pi over 6, that's the y value. So I will look, and I'll see the y value is negative 1/2. Now, this is where it's tricky. Tangent of 7 pi over 6 is the y value divided by the x. This is the y, this is the x. So if I do the y divided by the x, when you divide fractions, you multiply by the reciprocal. Negative times a negative is a positive. These fall out. So you get 1 over root 3. If you remember, you cannot have a radical in the denominator. So I'll rationalize that. And that will be positive because you're taking a negative dividing by a negative. Now if you look up here, secant is the reciprocal of this one. So if I did the secant of 7 pi